Hello everyone, welcome back to my channel. In this video we will explore how to evaluate a profile of line in Calypso. So open Calypso and follow along with me while I present the following practical example. For this example, I have prepared the drawing of this Alifix component and the CAD model. So, first of all, import the CAD model in Calypso, just like I did here. So the CAD model is imported. Let me open also the drawing. Okay, and according to the drawing, we have to make the datum first, right? So datum A, B, C to construct the alignment. Rename them. And apply a strategy, a measurement strategy. I will not apply a special strategy for this example. You can use whatever you want. I will use a simple strategy of points. Good. Now we can construct our base alignment. And we have defined our base alignment. Okay, let's define also the clearance cube. And for this example, we'll set the edge distance 10 millimeters from the margins of the CAD model, just like we can see here. And okay. Let's see what Calypso does. So for A minus Y, for B plus X, and for C plus Z. That's okay. And let's leave it like this. But our main interest is the line profile. So according to the drawing, we will have to make a line profile right here of 0.1 from K to J, right? Okay, so it's nothing really defined here. Usually we have a theoretical distance from this edge to where J is supposed to be and K is supposed to be, but I leave it like this because I want it to be free, okay? To show you something more. Okay, so let's create first the section, and I will create a section exactly in the middle right here. And to do that, we have to go to CAD model, creating features, and we have here a tab named section. Click on the CAD model and notice that the section is in the plane ZY plane, right? And we don't want it like this, we want it in the plane ZX. Okay, so how do we do that? We change the normal vector from here. Okay, so now it's on X, the plane X, the normal on the X axis, and we want it to be on the normal on the Y axis. Okay, 1. Okay, and now let's drag it a little, and you can play here also with the alignment. So think of these coordinates as the center of this imaginary plane, right? You see, if I move it, then it moves. It doesn't move on the Y axis because it's at 12.5 at the center of the part, but it moves on the X and on the Z axis, right? So notice right like this. And of course, if I move this, the expansion on the U and on the V increases or decreases as well, because this is the length and the width. And when you have something like we can see on the drawing, like here, and if it's defined, then you can calculate from the origin of the alignment where it is supposed to be. Okay, so let's say that the total width of the section is supposed to be at 70 millimeters, right? I think this is the width. Yeah, this is the width. 70 millimeters, the total width. And you want to start from here, let's say at I don't really know, this is 25, 30, I think 30 millimeters, and the total length of the part is 150. If you want to start at 30 millimeters from here, then you have to make sure that you subtract 30 millimeters from here and subtract 30 millimeters from here. Now, what this does helps you calculate exactly where do you want to go from where to where you want to stop. Okay, so according to that, let's leave it at 70 right here. And we want to start at 30 millimeters. We have to subtract 60 millimeters from 150. That means we have 90 millimeters left. 90 millimeters left. And we have to divide 90 millimeters at half and add the 30 millimeters. So 90 millimeters 45 with 30 millimeters, it's 75. And this is how you will manage to make a section according to a length defined in the technical drawing. But we don't have this length for this example. So this is the case where you don't have anything defined, you just want to make a section and you want to measure the profile of line on that section, right? Okay, so when everything is according to how you like it, just click this button named section and notice that Calypso did a section where you wanted to make. If you want to delete the sections that you will not use, just go to CAD, modify CAD entities, select the sections, and then click delete. Okay, we'll leave it like this, and now we want to select again this line and create our curve, because from a curve feature we will create the profile of line. Go again to the CAD tab right here, go to creating features again, but this time you have to make sure you are on the creation tab. Here Calypso will let you select the wire that you just created. With the control key pressed, you can select multiple wires, right? But you can also select one, just one, and select the other one with the control and click on contour completion, and Calypso will select everything for you. Now, it doesn't work every time. You have to be careful with this, but sometimes it works, especially when it's a simple section just like we see here. According to the length, we have to create a curve. Now, the points, from my point of view, have to be enough in order to get the desired tolerance that you have on the profile of line. So we have 0.1, and on this length, I think 500 points will be enough. And create curve. Okay, so you just created the curve. Good. Now, notice that the normal of the points is not according to what we want. So you can change that from this button right here. And now it's fine. And also we can notice that probably this doesn't look like 500 points, right? So if you want to see all the points with the curve selected, right click on the screen and you can display the measured points. You can show deviations, show masked points if you have something like that, and you can also magnify them, but it's not that important. And under magnification you can show the point numbers, and here we can see that actually the point numbers are from 5 to 5. So it's 1, 5, 10, 15, 20 and so on. But we can also show all the points. Go to properties, and here we can check this, all nominal points. And now we have all 500 points right here. But I do recommend that all nominal points should not be checked in order for the software to not be constrained of too many information. Okay, and now that we have it, we can also measure it. And I will measure it just the way it is, so you can see something, and then we will make some modifications, right? Okay, so we have to execute it. Okay, and let's see the measured points. Okay, look what we have here. See, this is really not good. Whenever you have edges, try to go above them. Just ignore them and do not measure until the end, right? Okay, same thing is here, because it's kind of the same thing. You see, you don't have enough information. And let me show you exactly what this means, right? So whenever you have something like this and you try to make a line profile, let's say that you don't want it according to ABC, you just want it with no datum reference frame whatsoever, right? And you have here 0.1. Okay, click OK and go and make a plot. Let me show you what happens whenever you try to do that. Notice right away that we have the minimum points and the maximum points right here where the problems are, right? And let's magnify a little because you can see it. Notice right here that we do have a little bit of information, but not so much. And here we have a disaster. Okay, so here notice that the point is very, very low according to the tolerances. And if you want to understand this, this is the legend. So intolerance, out of tolerance, out of warning limit, nominal values, tolerances, segment 1, and extreme points. So this is the segment, whatever you see here. This is the line that connects the points from the segment. And these are the points that exceed the tolerance. And here is the maximum point and the minimum point. And if you go like this with control, we have a deviation of 0.22 right here on point 250 and a deviation of minus 0.1057 on point 253. Okay, so yeah, not good. Do not do it like this. Just ignore the edges, and let's do that right now. So, in order to correct what we just did, let's go right here and say to Calypso, do not create the segment like this. Just go from the first point to point 25, 0.5 millimeters. Travel during scanning, right? Pre-post. That means that it goes 0.5 millimeters here and 0.5 millimeters here in order to catch all the information from here. You know that first, when Calypso tries to scan something, it has a 0.3 second where it masks the points whenever it starts because of the deflection of the stylus. The number of points, always the number of points here has to be double this number of points from here. So if we have 25 here, we have 50 here, because Calypso will calculate the point that is near to the surface. The point from here, for example, is in reality somewhere here. It will calculate it from here, not from here. Now on a flat surface, I don't know if that really matters, but on a curved surface, this is very, very important. Okay, so leave it like this, leave it at 3 millimeter speed, and it's fine. Now we have to create another segment. So, new curve segment, and now we will start from 30 and we will end at, let's say, 245. I think it's fine, or even 250. 250, okay, 250. So we have 220 points, so we will have here 440. Notice that the step will be from 0, 1, 1. So the step is from 0, 1 to 0, 1 millimeter. It will leave a point. Okay, 0.5, but I think it's too much because I don't want it to go like this. So on this case, we will not set anything here. We will leave it as it is. It's fine. Okay, then create another segment. From 255 until 470. Okay. Then from 475, but let's for it like this, 255. That means that we will have here 215 points, and that means that we will have here 430. Okay, leave it like this, and another segment from 475 to 500, 25 points, 50 points here, and leave it like this. Click OK. Click OK. Good. Now we have to make something else, because Calypso have to know exactly what we did here. So whenever you have something like this that we did here, and you do not go all around the surface, and you avoid some places from the scan, you will have to go to this tab right here and select actual to nominal. Now, actual to nominal, this is according to Calypso. The actual to nominal deviation means the distance between the point located on the actual curve that belongs to the measurement point and the nominal curve. So it takes the actual point, projects it on the nominal, and creates the calculation. Now let's see what happens if we do not do this. Okay, so let's leave it like nominal vector direction, right? Let's leave it like this. We have the same strategy like we see here that we did earlier. And of course we have to check this best fit, because it will take all the points and try to best fit them as best as Calypso can according to the nominals from the points and the origin of the alignment. So it takes the translations and rotations from here, okay, according to Gauss. All rotations and all translations. Of course you can mess with this, but you have to make sure that you know what you are doing. Okay, leave it like this, it's fine, and let's see what happens. Let's measure it. And let's check the line profile. Ooh, and we do have 0.8. Let's see why. I think 50 is too much this time. Yeah, I think 10, 20, 50, 40. Good. Now, see what happens here. Calypso tries to put points even on the parts that we avoided. That's why we have big deviations here. So that's what Calypso is trying to do. Trying to put points everywhere. Even here. See? Let's make a little bit bigger. See? We have points here, even though we didn't measure anything. But let's see. And let's see here. Here we can see it better, right? So the points are, deviations are enormous. Okay. Now, let's go back to the curve and set here actual to nominal. Okay. And to evaluation. Okay, so let's also filter the points. Okay. Okay. and remeasure the points again to see what happens. Notice that the deviation is now 0.17 and the first time it was 0.80 something, right? And let's see what Calypso did here. Okay, so see, it avoided everything. Now we don't have anything here. It knows that this is the contour, but we don't have anything here. This is still the lowest point from the profile, but it's intolerance. And the problem is actually right here. See, this is the biggest point. And we have the profile. And we can say to the toolmaker or whoever wants to correct the part that here is the problem, here is a little bit of problem, here and here. Maybe here a little. So we can see it, right? We can see exactly where the problem is. Okay, but we didn't respect, to say so, the asking from the drawing, because the asking from the drawing was to be the profile to be made from here to here. So we can do that with another characteristic. Okay, let's do that with the formal location, and now we have to take the curve form. Whenever we take the curve form, we can select the curve again, okay? And in the curve right here, if you select this button, you have these segment tolerances. Okay, so in order to use this, we have to change the number of points. We have to select exactly as it is, right? So here 25. Okay, here we have to leave it at 220, and also here on this one 215, and here 25, and we have to remeasure it. Okay, I do not quite recommend this because you don't have enough points on the curve. And now we can do this. Okay, so from 25, but to be more careful, we will take 30 and go to 455. 455. Okay. Okay, and I think it's fine like this. So you can have it in both way, right? So you can have it like this as well. Tolerance, evaluate tolerance segments individually because we want them individually, and we can also plot it to see what do we have here. The curve form with all the points on it, and we also have what did we want here, right? So 0.05 minus 0.05, and we have the measured value of 0.0757. This is the maximum. This is what we are supposed to find here. Yeah. Okay, so you can do it like this also, wherever you want, but I told you, if you do it like this, make sure you put enough points from the beginning on the curve. I usually work with the first example that I showed you, and I use this only for analysis, to analyze some points or to see something that I cannot see in the first example. But in the first example, as you saw, we can see almost anything. On this example, we cannot set the limit as the line profile wants it. So the limit is the half because it will show you each individual point. It will show you actually the measured value from the point, the maximum point measured, or the minimum, which one is the lowest on the value, which one exceeds better the tolerance. Okay, so I hope this video helps you with your work. I wish you a Merry Christmas, a Happy New Year, and I hope that I will see you in the new year with new forces. Have a great holiday. See you next time.